Hi everybody, this is Dr. Nigro with the second in our density videos, just so we can have an idea of how to do some problems that are a little bit more complicated than just manipulating the formula. All right, we're going to be looking at problems 4 and 5 in this video. Problem number 4 says you are given an unknown liquid. Using a graduated cylinder, you find that the cylinder's empty mass is 50.14 grams and its mass filled with the unknown liquid is 56.24 grams. The volume of the unknown liquid in the cylinder reads 25.40 milliliters. Determine the density in grams per milliliter. All right, so density problems we know have our three variables. We have density, we have mass, and we have volume. So if we look at our problem, we have a graduated cylinder. The empty mass is 50.14 grams, and the filled mass is 56.24 grams. We're also given the volume of an unknown liquid to be 25.40, and that's in milliliters. And we're asked to determine the density in grams per milliliter. All right, so we've got a volume value that's directly related to our substance, but we have two mass numbers. All right, so sometimes when we're using a liquid and we want to determine the mass, it can be difficult. You can't put the liquid directly on the balance. You have to put it in a container. And so we use what's called mass difference. So we want the change in the mass of our container, and that change is going to be equal to the mass of our liquid. All right, and whenever we see this delta symbol in a scientific formula in chemistry, it means the change, which is always going to be the final value minus the initial value. So in this case, our initial value was the empty, and our final value was the filled. So we take our 56.24 grams and we subtract from that 50.14 grams, and we find that the difference in those two mass values is 6.10 grams, and that is the mass of our liquid. All right, so now we have a mass value and we have a volume value. So we can go into our density formula, which is mass divided by volume, and we plug in those values, 6.10 grams. We divide that by 25.40 milliliters, and we find that our density for this particular liquid is 0.24 grams per milliliter. All right, so we check our answer's unit against what's the problem asked for, and we see that they match. The problem asked for that density in grams per milliliter, and after our calculation, that is exactly what we have. So we are all set for this problem. All right, let's slide down to number 5. An irregular solid with a mass of 0.00453 kilograms is placed in 12.56 milliliters of water, causing the water level to increase to 14.05 milliliters. What is the density of this solid in grams per milliliter? All right, so again, density, mass, and volume. We go look, we have a mass value first, 0.00453 kilograms. All right, we've got a volume measurement before the object goes into the water and a volume measurement after. All right, so we're going to be using that same idea that we did above, except instead of the change in mass, this time we're looking at the change in volume. All right, this experimental technique is called displacement. All right, and we use it quite a bit when we have these irregularly shaped objects. If we had a cube or a rectangle, we could use a ruler to determine the dimensions and calculate volume that way. But with irregularly shaped objects, it's a little bit more difficult. All right, so that change in volume is going to be equal to the volume of our object. And just like we saw above, it's going to be the final volume minus the initial. So if we look, our final volume of the water was 14.05 milliliters, and we're going to subtract the initial, which was 12.56. All right, so our difference in volume is going to be 1.49 milliliters, and that's going to be the volume of our object. So with that in mind, we can calculate our unknown, which is going to be the density. All right, so the density is equal to mass over volume, and here the mass is 0.00453 kilograms. Uh-oh, we have a problem. All right, we have a unit of kilograms, but the problem asks for that answer in just grams. So we're going to need to do a conversion before we can go into our formula. So we take our 0.0045 3 kilograms, and we convert that into grams. All right, now I want kilograms in the bottom of my conversion factor and grams up top so that they'll cancel. And I know based on my knowledge of the metric system that 1 kilogram contains 1,000 grams. So this conversion actually tells me I have 4.53 grams for the mass of my object. So I can take that number and go into my formula. 4.53 grams divided by 1.49 milliliters, and the density of our unknown object is 3.04 grams per milliliter. Now, could we have used the kilograms and found our density value in kilograms per milliliter and then done the conversion? Sure. I just think it's a little bit easier to do the conversion before you plug it in, but that doesn't mean that is the only way. Okay? All right. So, again, watch out for your units. All right? They are super important. And these two concepts of this change in mass or change in volume, also very important. Sometimes we're going to be given experimental data like this one, and we have to use that. Okay?